Hi there, I'm Will Sentance, the founder of Codesmith, and I am excited to share with you JavaScript The Hard Parts version 3. I created this course so that you could get an under-the-hood understanding of the tools of JavaScript that you might use every day, but understand them in a deep manner so that you can use them autonomously and effectively. We will cover higher-order functions, we'll cover closure, asynchronous JavaScript, type coercion, and object-oriented programming, and we're going to tackle them all on the blackboard so that you can go out into the world with these clear mental models so that you can build a career as an effective software engineer. We're about to do the most important thing in JavaScript. We're about to start executing a function which allows us to make a little mini program. In fact, it's going to make a mini version of what we were just doing, a thread of execution running through our code line by line, a place to store data, and it's known as an execution context. A space, a context, a place in which we can run some code, in which we can execute some code. There it is. I'm going to be drawing those quite a lot during our session. Into it, our thread, which is our fancy way of saying doing the code line by line. Into it goes, into multiply by 2, and immediately we get to create a new memory just for inside this function. It is known as a local memory, just available while we're inside the running of this function. Into it we go, and Tenzin, what is the first thing that we get to store inside this local memory of the function multiplied by 2?
It const results.
Almost. That's the second thing we're going to store. What's the actual first thing that we might store as we evaluate, as we run, as we execute multiply by 2 with the input of 3? What's our first thing we always do when we jump into a function?
The argument. Exactly.
And the argument's value is what?
3.
Excellent. And what is the name for the sort of like the identifier, the label we put there ready to receive that input number 3? What's the name for that?
How do you mean?
What do we call? We have our arguments and we have our parameter. Excellent. Thank you, Matt. And the parameter name, Matt, is what?
Input number.
Was that not Matt? Excellent. Thank you, Matt. Exactly. Input number is the value of our argument, which exactly as Tenzin said, is 3. And now, Tenzin, we do actually hit our little bit of math, which is to assign to result the value of input number, which is 3, multiplied by 2, which gives us what, Tenzin?
6.
Excellent. Thank you to Tenzin. And we then get the chance to return the value of result, which is 6, exactly. So it's going to evaluate to 6. That gets assigned to result. We then hit the key line, which is get us out of this function, return out. Do we return out result? I would say more precisely, we return out the value of result. That is the actual number. We lose the interior labels. They're forgotten. And we return out the value of result, which is 6. And in fact, people, our entire execution of this line evaluates, it turns into the output value of 6. And that gets assigned, turns into what global label? What global label do we assign the result value to from executing multiply by 2? We assign that 6 to what global label?
Output.
Output, exactly. Hooray, well done. And our execution context, people, the place in which we ran that code gets closed, and we weave our thread of execution. It threads its way in, it weaves its way in, does the code, it weaves its way out. Okay, we're out into global. Everything in outer, we're done. That was a one-time run of outer to get the add1 function now under a new global label, new func. This is a function formerly known as add1. And now we hit running that function. Joe, talk me through the next line of code. What function are we calling? We've just assigned a new func, add1 function.
We're calling the function definition of add1.
Oh, sounds good to me. Under what name, though?
New func.
New func, and we're creating a what?
New execution
Yeah,
context.
that's right. I hope everyone noticed
Func
there.
on the stack.
Yeah, put on the call stack. Beautiful. I hope everyone noticed there that Joe was like, we're calling the function definition formerly known as add1, but by its new label, new func. Go inside, new execution context, new local memory. There it is.
This is where I'm not a compiler, because I'm not sure if counter exists.
Well, let's just hit the line first. So what's the line? Now, we know we have to jump back up to look at add1's code, but JavaScript is looking inside the code here, and what's the line of code it sees to run?
Counter plus plus.
Well done. Counter plus plus. Where do we know it looks first?
It would look within the scope of new func.
Well, let's say the local memory, exactly. Let's say, the term is not bad, but do we find, probably should use green for my lookup, I think. I tend to use, no, that's fine, let's just use, I'll use white for now, but do we find counter in local memory? No. We're in new func. Where does everything suggest, Joe, that we would look next?
Well, if we looked by call stack, we'd go to global.
And do we find counter? No. I had to go. No. What do we do? Exactly as we heard there. To be fair, what sort of programming language will allow this sort of situation to arise where we can define a function inside of the call of another function, return out that function, have it refer to data that's not in local memory and not in global? That seems like a fundamental flaw. But as long as I'm going down the call stack, it all seems right. I don't know how long I meant to drag out. Unless it turns out, people, that as soon as I defined that add1 function inside the execution context, the running of outer, when it was on the call stack, I didn't just save a function definition. I also immediately got a hidden bond to I'll add a caveat to that later, to the surrounding data. So that when I return that function definition out, I didn't just return out a function definition, I pulled on the back of that function with it all of that surrounding data in a little, I have to tell you. So somebody in the audience once called this a backpack, and I will forever be grateful to them. So what comes into our backpack? Well, it is our counter with the actual value, not counter will be 0, not declare counter as 0, but the actual stored counter is this 0 in memory stored, is pulled out and attached with our function in the global label new func. New func is now the function definition, put parens on it and run it, and an attached live store of data. By the way, only available, we'll see, inside of the running of new func, which might give you some interesting pointers on what needs to be in there, but we'll come to. So with that in mind, Matt, because you've been so great at all this, new func is called, we don't find counter in local memory. While it would appear everything would say we go into our global next, what intercedes, where does JavaScript's interpreter go look first before it gets to global and gets sad? Where does it go and look first?
It goes to look in the backpack.
In the backpack. Excellent from Matt. It goes to look in the backpack. Where, what does it find, Matt?
Counter.
And does what to it?
Adds 1.
Adds 1 to it. Beautiful. In JavaScript, we get directly only access to this object via some sort of address. So we can think about that almost as like a zip code. And if you've done some other programming languages, you might know very well that this pointer to the underlying object in memory is something that we could even in some languages do math on. That we know this position in memory is something that we can evaluate to enable us to say, well, how much further in our memory is the next bit of free space that we can do some work in. In JavaScript, we just declare our user stored, we know our object's there, but it is important for what we're going to see here that we know that actually what we get in JavaScript is a link to this underlying position in memory. And the same thing with our user submitted. Rather than us directly storing our object in user submitted, we get that down here in our big old flexible store of data where we have our name will ID 105 and our position. Again, these are sort of informally defined. What we really know is it's a link to some position in memory. I'm calling it 10001, I'm calling it 1002, but really a position in memory. And as I say, in some languages, we can actually directly work with these numbers and use them to exactly specifically position data in our heap. Pretty cool. And we can do math, pointer math, work on those positions, addresses, locations in our computer's memory.
Or treat it as a function.
Or treat it as a function. Even better, Chris. So, what does that mean, Chris? We're actually comparing here that even though our objects look so similar, even though I feel like surely my user submitted and my user stored, they got the same stuff in them. They were the same. I didn't dwell on this enough. They were the same. What am I actually comparing when I use even my 3 equals? Am I comparing the contents of the objects, Chris?
No.
What am I comparing?
The pointers.
The pointers, the addresses, the references. Exactly. I'm comparing 1002. Is it equal to 1001? The position in memory. Is it the same position in memory? Is it the same location? And the answer is absolutely not. And so I get false. In fact, if I were to declare here, let's declare another link. I'm just going to put it here. Another link is going to be user stored. I am going to be assigning to another link, which I want, I shouldn't call it another link, I want to call it a backup. This is a backup. Surely I'm going to do a copy of user stored in that final line. Chris, am I doing a copy of user stored when I assign user stored to another link?
No.
Not at all. Instead, I am doing a copy of its address, its pointer, its reference to the underlying heap position in memory. Meaning another link and user stored, now they're the same. But they ain't a copy and they ain't a backup.